Another example of a horizontal circle is the banking of aircraft. So imagine what happens is this aeroplane is making a turn, and this is the center of the circle, so it's making a turn this way. All right. Now, what are the forces acting on the aeroplane? Definitely, you will have your weight downwards, then you have your lift force, and the lift force is always perpendicular to the wing, all right, and it's not always vertical, but it's perpendicular to the wing, because according to Bernoulli's principle, the pressure on top the wing here is lower than the pressure below the wing, so the difference in pressure will give you the lift force. But the pressure that acts on this surface will exert a force 90 degrees to the surface, which is perpendicular to the surface. All right. So, and the pressure due and the force due to the pressure on top will also be perpendicular to this surface, which is downwards. Since the force upwards here is bigger than the force downwards here, all right, it's because the pressure here is higher than here. So the difference in the two forces will give you your lift force. All right, so this lift force and this angle theta. So if we were to resolve these forces here, you will notice that if you resolve vertically, so what you will get is that this lift force will have two components as well. All right, so this is my lift force. All right, so the component L cos theta will balance the weight. All right, so L cos theta minus mg equals to 0. So y equals to 0 because you're moving in a horizontal circle, so vertically there is no motion, so it is in equilibrium. But if we resolve the forces horizontally, then you get L sine theta, all right, which is this component providing the centripetal force. So if you wanted to solve questions like this, all we have to do is to just take equation 2 divided by equation 1 again, and we get tangent theta equals to v squared over gr. Now, if the plane does not bank, meaning to say if the plane's wing was straight like this, it will not be able to complete a turn because there will be no force acting horizontally to produce the centripetal force. All right. So therefore, what happens is your aircraft has to bank, so that the lift force will be at an angle, which will be able to produce L sine theta that will provide the centripetal force. Now, notice that if it banks more, okay, you will get a bigger component horizontally, so it's easier to turn. But at the same time, the component L cos theta will become smaller, because when theta increases, your cos theta decreases. So what will happen is you have less component of the lift force here to balance the weight. So what will happen is the airplane may drop. So usually what the pilots will do to compensate for this drop is to travel faster whenever they make a bank, all right, so that they will be able to have a higher lift force to compensate for the drop due to the banking of the aircraft.